Today we're going to be focusing on a kata called the tennis-kata. For me, this kata is something that I use quite a bit. So for myself, when I'm learning a new programming language, it will be one of my go-tos because it's quite simple. And in terms of like pairing with someone who's new to test-driven development, I'll generally use this kata to kind of show the discipline of test-driven development, and also if I've got a short amount of time to pair with someone new. The rules are kind of simplified to real tennis. I think this is supposed to be a re-implementation of Wii Tennis, or at least the scoring mechanism behind it. Today we're going to use Ruby as our programming language. I don't yet have a project set up, but I do have a directory. I also have an editor. I use RubyMine a lot of the time, but I've just got an empty folder with no files in it whatsoever. So I'm going to go ahead and initialize a new project. So I need to initialize a new bundle project, which will hopefully give me some files. So get myself a gem file. And I'm going to remove this line here. I'm going to replace it with RSpec because I quite like RSpec. Let's go ahead and fix all auto-correctable problems. I'm going to install our gems. So now I've got RSpec installed, and I can now run RSpec init, which will then initialize my new spec helper and my new .rspec file. By default, this gives us a lot of stuff that I'm not sure that I kind of want. So I'm just going to remove all of these comments. I'm not sure that I care about these comments. I have a feeling that some of these can be useful. I quite like without disabling monkey patching just because it's a little bit simpler to get going with. But I do like the fact that it runs in a random order. Let's go ahead and indent this entire block. Cool. And I think that Robocop's also complaining about this file, so let's go ahead and autocorrect. And if I run bundle exec RSpec, I should see no examples because we haven't got any spec files. I also don't like the fact that it creates this examples.txt, so let's get rid of that. I don't really want a profile either. Let's rerun that. Cool, so it still works. Excellent. Let's create ourselves a new test file. So we want to create a new tennis spec. So the rules of this kata, or at least the requirements of this kata, require that you be able to score a game with two players, and they can score from no points right up to 40 points. If you have 40 and you win the next ball, or rather the ball that you're on, you win the game. Although if the other person's on 40, then you are in advantage, so you have to win by 2 clear points. There's an alternative description down here. And I quite like this scoring, the way that this score looks, so I'm going to be reusing this as kind of like the English sort of shout-outs that an umpire will use, and we'll see that in a moment. So with TDD, we know that we should start with the degenerate test cases. So these are the tests that are the most simplest, right? So in this example, I think the simplest test case could probably be centered around this 0 case. So let's go ahead and write some tests. So let's describe tennis scorer. It can score a new game where no player has scored yet. So our expectation is going to probably be the score is going to be a string with love, which is using this kind of format down here. And the way that I'm separating it is this is player 1 score and this is player 2 score. I think this is going to fail still. And it's going to fail because we haven't defined tennis scorer. So let's go ahead and define that. Cool. So that should bring us on to this, this variable that I'm using. So I'm using this pattern where you write the expectation first. So you start with the last part of your test. And that's because I quite like using it because it forces you to think about what the simplest thing that you need to make some test pass without having to worry about doing a lot of setup. And we can bring the setup in later. So let's create a new variable, score, and that's going to come from some method. So the game, or rather the tennis scorer, is going to have some method, probably score. In Ruby, this might be getScore. In Java, this might be getScore, but in Ruby, let's just call it score. So let's call this other variable, tennis score. I'm going to need to initialize our tennis scorer. So I think that's now going to give us another error message, and that's because we haven't defined a score method. So let's go ahead and do that. And if we make this return nil, we should see the failing test that we expect to see, which is that we're returning nil, but we expect love, love. So following the discipline, let's make this pass in the simplest way possible. So let's get this to return love, love. And it passes. So this is our first test. Our first simplest test written, our first simplest test passing, and let's look to do some refactoring. So I've just removed some lines, just empty white space, just make empty white space here. In terms of like other refactoring, I'm not sure that there's any opportunities. Could potentially, I mean, we could potentially inline this. That might be a little bit better, but I'd like to see some more test case examples before going further with our refactoring. Yeah, just maybe this might make more sense. Cool. So let's write another test case. Can score a game where one player has scored once. Let's make it player one, where player one has scored once. So we're going to need something very similar. So let's write our expectation first. Tennis scorer dot score to equal 15, following these rules. So 15, love. We still need that variable. This isn't going to work yet. So let's create that tennis scorer variable. And we're also going to need some setup in this test. So we're going to need to indicate to this tennis scorer that somehow player one has won a point, so they've scored once. So let's say 1 point. At the moment, I'm not sure I need to specify that it's player one that's winning a point. I think we can add that in later. We can safely just continue with the idea that only player one can score a point at this stage. I think that keeps it simple. So let's create this method 1 point. So that's moved the failing test along one more time. Now we're getting the kind of expected failing test that makes sense for this stage. So although we're calling 1 point, we're not actually doing anything in that method, which certainly won't make this pass. So perhaps one way to make this pass is to extract this as a variable so that we can change it. So we could create a constructor, and if we want to extract this as a variable, then I'm going to need double quotes. So my first refactoring here is just to move it into a local variable, and I think that will keep the first test passing. So everything's good still. And then my second refactoring is going to be to make this a field. So now this should still pass. And then my last refactoring is just to move where this gets initialized up into the constructor. And that should still keep the first test passing. Perfect. And then I'm going to update that score. So when we win a point, we're going to update that to 15. Which makes that second test pass. Although we're still not done, this is clearly not going to work for our future cases. So let's go ahead and make those changes. So kind of maybe a third test could be to continue along this line. So what happens when player 1 has scored twice? So the next score is 30, so we'd expect this to be 30 love. Let's go ahead and see what that looks like. And we can call that method twice, so every single time we call that method is going to indicate to the tennis scorer that player 1 has scored another point. So in this case, they've scored twice. Let's go ahead and run that. Cool, so that's the failing test that we expected. And now we need to go ahead and think of a way to make this, this code here make a different decision based on the current score. So perhaps one way to do this is to go if score is love, then that's 15, else score is 30. I think I've got a double equals there, which would have failed. Let's go and watch this pass. Cool, so now we've got ourselves a passing test. I think there's some refactoring we could do. I'm not sure about this code yet. There's a rule around duplication, and that's you wait for three levels of duplication. And I'm not sure we've reached that yet. There's certainly some stuff that Robocop thinks that could be cleaned up here, but I think we can wait for the next test to kind of get to a point where we can clean that up. But down here in our tests, we've definitely got some duplication. So these 3 lines here are clearly duplicate code. So in RSpec, there's a really nice feature, let blocks, where we can define a variable that gets cleared out between each test. So let's go ahead and extract this into an if block. Let block. So that should go ahead and still pass. Cool, everything still passes. And let's just double check that it's not passing because I've broken the test suite. So if I change this string here, I'd expect all 3 examples to fail, which they do, so that's great. We're still testing stuff. Cool. Is there anything else that we could refactor? Potentially one option to do down here is that we turn this into a block. And that looks a little bit nicer. We can also extract an assertion method for this block here. So the way I'd usually do that is I would extract out the expected score, and then extract a method, expect score to eq, and then RubyMine will helpfully replace the other 2 blocks. And that should still pass. And then we can go ahead and inline that variable that we don't need anymore. And that looks just a little bit nicer. I'm going to move this, this helper method back inside the describe block. I think it makes sense to be outside. Cool. That passes. Nice. So let's go ahead and write our next test. So I think we're on to 30. We haven't yet reached 40. So let's go ahead and implement that. So we want to check when player 1 has scored thrice. So that means we're going to be expecting 40 love and 1 more point and they've won. So that fails for the reason we expect. We expected 40 love, but we got 30 love. And we can go ahead and make that pass by making this an else if block. We can go ahead and check the score is equal to 30. And we can change the score to 40. Does make sense if that is 3 times. Let's go ahead and undo that code, because I don't know whether you noticed, but we didn't have the test failing 100% correctly. So that does still fail, and when I introduce this code back, it passes. So with that correction to the test, it fails for the correct reason. Cool. In terms of refactoring, now that we've got everything passing, these tests look still pretty good. Not sure there's anything we could do here. Up here, there's definitely some opportunity around this if statement. So I'm wondering whether we can take this towards some sort of lookup table, which contains like a mapping of what should happen next, and this kind of gets us away from using if statements and moves us closer to a more cleaner solution that's based on sort of like a more functional style, or at least a constant style. So perhaps we could extract a way of doing this. So perhaps one way of doing this is to extract out score. And we want this to be a hash which has a lookup from perhaps love to 15. And what we're going to do is we're going to make this last one very explicit. So if the score is equal to 15, then we're going to go to 30. And that enables us to remove this first part of the if block. And then for the first part of the if block, we're definitely using the score lookup. So that should remain passing. It does not remain passing. And the reason for that is because the final line here is not score. That's not passing. So let's go through one at a time. So in our first test, we expect when you've scored twice, which should originally put you onto 15, and then it should put you onto 30. So we've got 15 here, so expect the score to be 30. But it's not doing that, and the reason it's not doing that is because it's updating the score too soon. So if you look, this if block here is reliant on the fact that the score has been updated. So let's move this below the if block and see what happens. Okay, we've got less failing tests. So the issue that we've got is that this is still being run. So let's put this inside an else. Cool, so everything passes again. So now every case that is not covered by these two here is this is now being run, which is close to what we wanted. Nice. Let's remove some more of these else if blocks. So the next one I'm thinking is 15, and that wants to be replaced with 30. And if we remove that block, everything should still pass, which it does. And let's do the last one, which is 30 to 40. No, I don't want the guided tour. Let's remove this last block. Should be able to remove everything. And everything passes. Let's just clean this code up, so we should be able to change that. I don't know whether you noticed, but I assumed that at one point was returning something during all of that, and I was actually mistaken. But it just goes that the human mind is finds it very difficult to reason about code, even code that's very simple like this. So it's good to stay on a testing path and stay focused using your TDD discipline. We've got to a solution here that doesn't need, I don't know whether you noticed, but this at score never did anything throughout all of that, and that is an honest mistake. So everything still passes. Cool. I'm going to leave that there for now today, and I'm going to pick this up in a part 2.